Okay, it's time for our fourth and final stage in the implementation of our primary functionality for TP camera. So let's come back over here. Now we're at TP camera stage 4, and this is really focused on one particular method, which is named
update position.
Update position. Now this will be a really quick theory lesson because the hard part has already been handled. All we're going to do is calculate a position. And so let's just going to cook it this way. So, boom. We're going to calculate a position. Now I'm going to leave some blank spots under that because that's a little bit involved, and we'll talk about how it's involved here in just a minute.
Right, and people are probably going, well, isn't that what we did in the last video?
We did, but what we calculated, if you remember, was a desired position. We haven't calculated our final position as a result of all of the smoothing we're going to need. That's what we're going to do here, but we'll get to that. So if we need to calculate a position. 2, we need to assign that position.
Which means we actually move our camera, finally.
Yep. And we'll even write that down. Move the camera.
Finally.
Yeah, I mean, just do a little cheer. And then the last thing we're going to do is look at target look at. Because that's what handles our orientation. That's all there is to it. Now, calculating our position is only slightly more interesting than it might seem at first. We need a position X, and let me write that just a little more cleanly, sorry. So we need a position X, we need a position Y, and we need a position Z that we can feed into a final... What is it, a variable technically?
Well, it's a position, so it's going to be a vector 3. So.
Okay, well, we're going to feed that into a final vector for position. Each one of these is going to require... Actually, let's just write it once so I don't have to write it a whole bunch of times. Is going to require smoothing. We already talked about how this works. So if you are unfamiliar with the concept of smoothing, please jump back to the previous theory video where we talked about the calculate desired position. Because we went into some extremes. Just real quick, just so that, you know, if you didn't see it, you're not completely left in the dark. We have, in this case, position, though it doesn't really matter. Really, you have some value over time. That's the critical thing to keep in mind.
Right.
It's just, in fact, just to make sure there's little confusion, we're just going to say value over time. All you need is a start value, you need an end value, which we now have, because we have calculated our desired position. So we've got start, or our current position, however you want to look at it. We have our desired position. The smooth function is going to make a curve that jumps between the two. We just need a couple of more pieces of information. We need how long this curve needs to last over time. So I'm going to say time of transition, so we'll just abbreviate that to time of trans.
Right.
And then we need some sort of value that we can store this in, or velocity value that we can store. So I guess it'll be a vel position.
Right.
And that's all there is to it.
Right.
Once we have all of those things, we can plot this out. Now, just like before, while we're running the smooth, we're going to be sending that back into each one of these values. So what we're getting is kind of a compressed smoothing. It's not 100% perfect exactly as defined by the curve, but it is going to smooth.
It's close enough for what we needed to do.
Right. It is going to smooth, and we do have control over how quickly that's going to smooth. But if you notice that it's not a perfect one-to-one relationship on your time, you'd be right. That's just how it's working.
Right.
That's it. That's all there is to it.
Right. Now, there is a way that we could actually take our start position and desired position as a vector 3 and smooth it all at once. We don't want to do it in this case, which is why we're breaking it up into a position X, position Y, and position Z, because we want to be able to smooth our horizontal motion independently of vertical motion.
Right. If we need to change the timing on those. Because really, if let's just say your camera's not doing a whole lot of rotating up and down, and you know, if your character falls, because that's going to be a part of it too, You're going to handle how that smoothing is going to take place, whether the character is going to, I mean, if it's too much, the character will probably appear to fall away from the camera a little too fast.
Right.
You got to handle all of that. So, and you don't want everything to just be slave to a single value. So we simply break it up.
Right.
Now, in short, what are we really going to need to get this done?
Well, we're going to need an X smoothing factor, or an X smooth.
Okay. Let me drag this kind of up and out of the way, and then we'll just continue on up here in the blank space. So we need an X smoothing factor.
And we're just going to call it X smooth.
Mm-hmm.
We need one for Y. So this is the time that we're going to allow smoothing for X and Z. It's going to be covered by X smooth. And the amount, or the time of smoothing for the Y is covered by Y smooth.
Right, so this guy will actually handle X and Z positioning, which, if you haven't thought about it yet, that is the motion along our orbital. Then Y smooth will just be separate and native to that, and that, here, let me draw it out here so I have a little more room. So these guys control that, and then our other arc, which moves us up and down within our limits, that's going to be handled by Y smooth.
And because we're splitting it out in the 3 different smoothing operations, we have to keep track of 3 different velocities. So we're going to have a velocity X, Y, and Z by VEL X, VEL Y, and VEL Z. And those will be,
those are required for the smooth damp operations.
Right. We're also going to need a vector 3 to hold our position.
Are we going to call that position?
Yes. And it'll be private source, lowercase p.
And I'll just put that in quotes just so we know that's a name. That's what we're going to call it. What else do we need?
That's it as far as fields.
Okay.
What we need to do is process that inside of update position.
Which is going to be with that same smooth damp operation?
Yes. We're just going to do it 3 different times, one for X, one for Y, one for Z. We're going to create a new vector and assign it into position using what we get back, which will be position X, position Y, and position Z. We assign that to our transform's position, and we tell our transform to look at our target lookout, and we're done.
Cool. Well, I mean, really, there's not as much to discuss here because we're not really seeing anything particularly new at this point. We already know how smoothing works, even though I did go ahead and review it. So without any further ado, let's go ahead and call this video a wrap, and let's jump in and get this coded. So that'll take care of this video. Thanks a lot.